It might seem strange, but electricity can sometimes be found in water, even in household sinks. There are several reasons why this could happen. Firstly, grounding problems can cause voltage in water. If electrical wiring or plumbing is not correctly grounded, stray voltage can leak into the water supply. Appliances or fixtures that aren't properly grounded can also provide a route for electricity to enter the water. Secondly, cathodic protection systems might be a factor. These systems protect metal pipelines from corrosion by introducing a low-voltage electrical current into the water using sacrificial anodes. Thirdly, electrolytic effects can play a role. When different types of metals, like copper and steel, are connected in a plumbing system with water present, they can form a galvanic cell. This cell generates a small electrical current. Fourthly, static electricity can build up. In dry conditions, flowing water can accumulate a static charge. When you touch the faucet, this charge can discharge, giving you a slight electrical shock sensation. If you suspect there's voltage in the water, you can use a non-contact voltage tester to check. Hold the tester near the running water. If the tester indicates voltage, it's important to call a qualified electrician or plumber to investigate and fix the problem. If you think there might be voltage in the water, a few safety steps should be taken. Unplug any electrical appliances that might be connected to the sink. Also, avoid touching the faucet and running water with bare hands until the problem is fixed. It's crucial to contact a qualified professional to address the issue quickly to ensure safety and prevent damage to appliances or electrical components. To reiterate the potential causes: 1. Grounding issues can introduce stray voltage into the water supply due to faulty wiring or improperly grounded appliances. 2. Cathodic protection systems used for pipelines can inject voltage into the water. 3. Electrolytic effects from dissimilar metals in plumbing can create a galvanic cell and electrical current. 4. Static electricity buildup from flowing water can discharge when touching the faucet. Now, let's elaborate further on grounding issues. A proper grounding system is essential for electrical safety. It provides a low impedance path for fault currents to return to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. If the grounding system is compromised due to loose connections, corrosion, or improper installation, stray voltage can find its way into the plumbing system. This is especially true if the metal water pipes are used as part of the grounding electrode system, which is common in older homes. In this case, any electrical fault in the house can energize the water pipes and, consequently, the water itself. To mitigate grounding issues, it is essential to have a qualified electrician inspect the entire electrical system, paying close attention to the grounding connections at the service panel, grounding electrode conductor, and all branch circuits. Any loose or corroded connections should be tightened or replaced. If the grounding electrode system is inadequate, it may need to be upgraded by adding additional ground rods or a ground plate. Now let's expand on cathodic protection systems. Cathodic protection is a technique used to prevent corrosion of buried or submerged metal structures such as pipelines and storage tanks. There are two main types of cathodic protection: impressed current and sacrificial anode. Impressed current systems use an external power source to drive a direct current through the soil or water to the metal structure, making it the cathode and preventing corrosion. Sacrificial anode systems use a more active metal, such as magnesium or aluminum, which corrodes preferentially to the protected structure, providing cathodic protection. In both types of systems, a small voltage is intentionally introduced into the surrounding environment, including the water. While this voltage is typically low, it can sometimes be detectable in household water supplies, especially if the cathodic protection system is located nearby. To address potential issues related to cathodic protection systems, it is important to ensure that the system is properly designed, installed, and maintained by qualified professionals. The voltage and current level should be monitored regularly to ensure that they are within acceptable limits. If excessive voltage is detected in the water supply, it may be necessary to adjust the cathodic protection system or implement additional measures to mitigate its effects. Now let's delve deeper into electrolytic effects. Electrolytic effects, also known as galvanic corrosion, occur when two dissimilar metals are in contact in the presence of an electrolyte, such as water. The more active metal corrodes preferentially to the less active metal, creating an electrical current. This current can be detected as a voltage in the water. In plumbing systems, electrolytic effects can occur when copper pipes are connected to steel or galvanized pipes. Copper is more noble than steel or zinc, so the steel or zinc will corrode preferentially, releasing metal ions into the water and creating an electrical current. To minimize electrolytic effects in plumbing systems, it is best to use similar metals throughout the system. If dissimilar metals must be used, they should be separated by a dielectric union, which prevents electrical contact between the metals. It is also important to ensure that the water is not overly corrosive, as this can accelerate the corrosion process. Water softness can sometimes increase the corrosivity of water, so it is important to monitor the water chemistry and adjust the treatment accordingly. Lastly, let's consider static electricity. Static electricity is the buildup of electrical charge on the surface of an object. It is typically caused by friction or contact and separation between two materials. In dry conditions, flowing water can build up a static charge as it moves through the pipes. This charge can be discharged when you touch the faucet, giving you a sensation of a slight electrical shock. Static electricity is more common in areas with low humidity, as dry air is a poor conductor of electricity. To minimize static electricity in plumbing systems, it is helpful to increase the humidity in a building. This can be done by using a humidifier or by simply running the water for a few minutes before touching the faucet. In addition to the troubleshooting steps mentioned earlier, there are other things you can do to investigate and resolve the issue of electricity in tap water. 1. Check the grounding of all electrical appliances and fixtures in the house. Make sure that all grounding wires are properly connected and that there are no loose or corroded connections. 2. Inspect the plumbing system for any signs of corrosion or leaks. If you find any corrosion, it is important to repair or replace the affected pipes. 3. Test the water for electrical conductivity. A high conductivity reading can indicate the presence of dissolved metals or other contaminants that can contribute to electrical current in the water. 4. Consult with a qualified electrician or plumber to perform a thorough inspection of the electrical and plumbing systems. They can identify any potential problems and recommend appropriate solutions. To reiterate the safety precautions, if you suspect that there is voltage in the water, it is important to take the following steps. 1. Unplug any electrical appliances that may be connected to the sink. 2. Avoid touching the faucet and running water with your bare hands. 3. Contact a qualified professional to address the issue promptly. By following these safety precautions and troubleshooting steps, you can help to ensure that your water supply is safe and free from electrical hazards. Furthermore, consider these additional points. The presence of voltage in water can be intermittent. It may only occur at certain times of the day or under certain conditions. This can make it difficult to diagnose the problem. If you are unable to detect voltage in the water using a non-contact voltage tester, it does not necessarily mean that there is no problem. The voltage may be too low to be detected by the tester, or it may only be present intermittently. In some cases, the sensation of electrical shock may be caused by other factors such as nerve sensitivity or muscle spasms. If you are experiencing persistent symptoms, it is important to consult with a doctor to rule out any underlying medical conditions. When contacting a qualified professional, be sure to provide them with as much information as possible about the problem. This includes when the problem occurs, what you feel when you touch the faucet, and any other relevant details. The more information you can provide, the easier it will be for them to diagnose and resolve the issue. Finally, it is important to remember that electricity and water can be a dangerous combination. If you suspect that there is voltage in the water, it is important to take the problem seriously and seek professional help. Do not attempt to diagnose or repair the problem yourself, as this could put you at risk of electrical shock. Let's talk more about testing the water for electrical conductivity. Electrical conductivity is a measure of how well a substance conducts electricity. Water with a high concentration of dissolved ions, such as salts, minerals, and metals will have a higher electrical conductivity than pure water. The electrical conductivity of water is typically measured in microsiemens per centimeter. The normal range for drinking water is between 50 and 1000 microsiemens per centimeter. If the electrical conductivity of your water is significantly higher than this range, it could indicate the presence of contaminants that are contributing to electrical current in the water. There are several ways to test the electrical conductivity of water. One way is to use a handheld conductivity meter. These meters are relatively inexpensive and easy to use. Simply insert the probe of the meter into the water and read the measurement. Another way to test the electrical conductivity of water is to send a sample to a laboratory for analysis. This is a more accurate method, but it is also more expensive. If you suspect that the electrical conductivity of your water is high, it is important to have it tested by a qualified laboratory. They can identify the specific contaminants that are present in the water and recommend appropriate treatment options. Now let's examine the role of qualified professionals. When dealing with electricity and water, it is always best to err on the side of caution and seek professional help. A qualified electrician or plumber has the knowledge, skills, and experience necessary to diagnose and resolve the issue safely and effectively. An electrician can inspect the electrical system for any grounding problems, wiring faults, or other electrical hazards. They can also test the voltage and current levels in the water to determine the source of the electricity. A plumber can inspect the plumbing system for any corrosion, leaks, or other plumbing problems. They can also test the water for electrical conductivity and identify any contaminants that may be present. When choosing an electrician or plumber, be sure to select a licensed and insured professional with experience in dealing with electrical and plumbing issues. Ask for references and check online reviews to ensure that they have a good reputation. It's important to communicate clearly with the professional and provide them with as much information as possible about the problem. This will help them to diagnose the issue quickly and efficiently. Remember, addressing electricity in tap water requires a systematic approach. Begin by identifying potential causes, such as grounding issues, cathodic protection systems, electrolytic effects, and static electricity. Then, use a non-contact voltage tester to check for the presence of voltage in the water. If voltage is detected, take safety precautions such as unplugging electrical appliances and avoiding contact with the water. Finally, consult with qualified professionals to inspect the electrical and plumbing systems and recommend appropriate solutions. Stay vigilant and proactive in addressing this issue. By understanding the potential causes, taking appropriate safety precautions, and seeking professional help, you can ensure that your water supply is safe and free from electrical hazards. And remember, regular maintenance and inspections of your electrical and plumbing systems can help to prevent these types of problems from occurring in the first place. This includes checking the grounding connections, inspecting the pipes for corrosion, and testing the water quality. By taking these steps, you can protect yourself and your family from the dangers of electricity in tap water. Let's also consider the age of the house and its impact on potential electrical issues. Older homes often have outdated wiring systems that may not meet current safety standards. This can increase the risk of grounding problems and other electrical hazards. If you live in an older home, it is especially important to have the electrical system inspected by a qualified electrician. They can identify any potential problems and recommend necessary upgrades. Even in newer homes, electrical problems can still occur. Improper installation, faulty materials, or damage from rodents or insects can all lead to electrical hazards. Regular inspections and maintenance are essential for ensuring the safety of your electrical system, regardless of the age of your home.